Welcome to 1.3. Today we are going to add, subtract, multiply, and divide real numbers, simplify expressions using exponents and roots, and practice the order of operations in order to simplify and evaluate algebraic expressions. All right, so we went over the learning objectives. Now let's start with combining real numbers. So to combine, when you want to combine or when you hear combine, think of add, okay? If the numbers you are adding have the same sign, add the absolute value. So remember, an absolute value is just the number without the sign. So -9, the absolute value of -9 is going to be 9. So when you hear the absolute value of a number, you're thinking of that number on a number line and how far that number is from the number 0. For example, starting with -9, -9 is 9 units from 0. So it'll always be a positive number. To add two real numbers with the same sign, add their absolute values, so ignore the signs, and keep the common sign. For example, -2 combined with -4 becomes 2 plus 4 is 6. The common sign is the negative sign, right? Alternately, +13 and +5 13 and 5 is 18. The common sign is a positive sign, so you're not going to change it to a -18. Basically, the only news here is that if you have two negatives and you're combining them, you can just add them and then keep that, the total, the last number, keep the answer negative. All right, what if they have different signs? If they have different signs, you're going to subtract them from each other. Take the smaller one, subtract it from the larger one, keep the sign of that larger one. All right. For example, if this was a +2 combined with a -4, right? Those are different signs. This is a positive sign, this is a negative sign. Subtract the smaller absolute value. So remember, for absolute value, the absolute value of 2 is 2, and the absolute value of -4 is 4. So you're just looking at the number without its sign. Which one's bigger? The bigger one is 4. So we're going to subtract the smaller, subtract the 2 from the 4, then keep the sign of the bigger one. So 4 minus 2 is 2, but keep the sign of the number with the larger absolute value. That means it's a -2 because this was a -4. The 4 is the bigger of the two absolute values. Keep the sign of the number with the larger absolute value. Good. Or if it was -2 and +4, same subtraction, right? Subtract the 2 from the 4 because the 2 is the smaller, the 4 is the bigger. 2 minus 4 is 2, but the 4 is now a positive, so it's a +2. Good. Here, 13 and 5, if it was a -13 combined with a 5, you would subtract 13 minus 5. Don't hesitate to use your calculator. There's nothing wrong with it. 13 minus 5 is 8. Good. But keep the sign of the number with the larger absolute value. This is a -13. 13 is bigger than 5, so it's going to be a -8. Alternately, if it was 13 plus a -5, it's just 13 minus 5. 13 minus 5, we just did on our calculator. It's still 8. In this case, the 13, the bigger absolute value, is a positive, so it would be +8. Okay? -14 plus a -9. That is the case of same sign. They both are negatives, okay? If they have the same sign, add their absolute values and keep the common sign. So 14 and 9 in your calculator gives you a 23. But then what did it say? It said keep the common sign. The common sign is a negative. So -14 plus -9 is a -23, just like -14 minus 9 would also be a -23. the same problem. Here, though, we have different signs. So different signs, because this is negative, but this is not negative. If it's not negative, it's positive, right? If they have different signs, subtract the smaller 11 from the larger. One second. Let's look at absolute values. So we have the absolute value of negative 11, which is just going to be 11. And we have the absolute value of 18, which is going to be 18. Subtract the smaller absolute value from the larger absolute value. That means we basically have 18 minus 11, which if we flipped them, we would have 18 minus 11. 18 minus 11 gives us 7. Oh, I'm sorry. 18 minus 11 is 7. Keep the sign of the number with the largest absolute value. The largest absolute value is 18. It was a positive 18, so it's a positive 7. Negative 11 plus, 18 is 7. Good. Here we have, again, we have different signs. So that's a positive 8, but a negative 13. Subtract the smaller absolute value from the bigger absolute value. 13 minus 8 is 5. But keep the sign of the bigger absolute value. So it's actually negative 5, which you can also put in your calculator. 8 plus negative 13, or 8 minus 13, negative 5. Negative 21 plus 12. Go ahead and pause the video. See if you can do A, B, and C by yourself, and then see if I get the same answer as you when I do them. Here, these are different signs, so we're going to subtract. 21 minus 12 gives me 9. The sign of my bigger number is negative, so it's a negative 9. Here again, we have different signs. 22 plus negative 9 means we're going to subtract them. 22 minus 9, because 22 is the bigger number, 9 is the smaller number. 22 minus 9 is a positive 13. The sign of 22 is positive, so that's going to be a positive 13. Okay. Again, we have different signs because this isn't positive or negative, it's neutral, and then we have a negative 12. So 0 plus negative 12 is, I guess we would say 12 minus 0 is 12, but the sign of 12 is negative, so it's a negative 12. All right. Here we have fractions, right? This rule still applies. The two rules we're practicing still apply, but we also need to incorporate rules of fractions into problem D, okay? What are the rules of fractions when you're adding fractions? It is, in order to add or subtract fractions, we need a common denominator. What number, our denominator is the bottom of the fraction. So the top of the fraction is called the numerator. The bottom of the fraction is called the denominator. So in order to add fractions, you need what is called a common denominator. You need the 5 and the 3 to be the same number. How do we get 5 and 3 to be the same number? We need to find a common number that's bigger than 5 and bigger than 3, that I can take that number, I can divide it by 5, and I can divide it by 3. The fastest way to do this, it sometimes might be a big number, problematically big, but the fastest way to do this is to take your number, like the second number, the 3, multiply it by the 5. 5 times 3 is going to be 15. And then over here, we'll take the 3 and we'll multiply it by that 5, and we'll get a 15 here. So that'll be 15 and that'll be 15. You solve the problem by multiplying this number by that number, and then over here on this side, multiplying this number by that number. With a fraction, if you're going to take the bottom of the fraction and multiply by 3, in order to preserve equality, you need to also multiply the top of the fraction by 3, because that just ensures you've only multiplied by 1. And -4/5 times 1 is still -4/5. You're preserving the equality by multiplying by the same number on the top and the bottom of the fraction. So we're going to take that and we're going to multiply that by your original fraction, -4/5. When you're multiplying fractions, you just go straight across, right? So 3 times -4 is going to be -12. 3 times a +5 is going to be a +15. So it's going to be -12, +15. Here, let's put a plus. Here we have 2/3, but remember here we're multiplying by 3. So here we're going to multiply by 5. You'll see that that turns it into a common denominator. The denominator will now be common to both sides, both fractions, so that you can complete the math problem. So here we're taking -4/5, multiplying it by 3/3. Here we're taking +2/3 and we're multiplying it by 5/5. What do we get? We get straight across. 3 times 4 is a -12. 3 times 5 is 15. 2 times 5 is 10. 3 times 5 is 15. Is that okay? If not, feel free to Google how to add fractions. There are better videos, better math teachers than me who can help you. Once you have what is called a common denominator, so that 5 and that 3 are now both 15. We made a common denominator. Congratulations. By multiplying the denominator, each denominator by the other denominator. So now that you have common denominators, you leave that denominator the same and you just add the numerator, the top number. -12 plus 10, remember we said that those are different signs. So you take 12 and you subtract 10, because 12, absolute value of -12 is bigger than the absolute value of 10. 12 minus 10 is 2, but that 12 is a negative, so it's a -2/15 is my final answer. Good? You can also put that into your calculator. There's nothing wrong with doing all of this via calculator, okay? Here, we're still just combining. 6 minus 10, you can look at that as 6 plus a -10. So the bigger number is the 10, it's a negative, so I know my answer is going to be negative. 10 minus 6 is 4, so it's a -4. -14 minus 19, that's the same sign, so I can just add 14 and 19. It's a 33, and I'm going to call it a -33 because the common sign was negative. Good? Here I am subtracting, so before I do anything, I want to take this and convert it, okay? So let's think about this. Minus a negative number is the same as adding that number. So anytime you have a minus sign followed by a negative sign, what you can do is you can just turn that into, you just turn it into a big old plus sign. That is now -12 plus 6, okay? -12 minus -6 is going to give me -6. -12 plus 6 is also going to give me -6, okay? So that's now a positive. Those are now different signs. 12 minus 6 I know is 6, but the sign of the bigger absolute value is negative, so it's going to be a -6. Same thing here. 6.9 minus a -1.8 is going to be 6.9 plus 1.8. Now those signs are common, so you can just put them in your calculator. 6.9 plus 1.8, 8.7. Good? All right. Here, ooh, sorry. If it was multiplying, that'd be way easier. But it was just that I forgot to add a plus sign. So it's negative 3/4 plus negative 4/5. All right, let's do the exact same thing we did up on part D of example 2, okay? We said our numerators are 3 and 4, our denominators are 4 and 5. Those are not two fractions with common denominators. You need common denominators, so what we're going to do is we're going to take negative 3/4 and we're going to take negative 4/5 and we're going to multiply them by something to give them a common denominator. Here we multiplied 5 by 3, got 15, multiplied 3 by 5, got 15, okay? If you can think of a different number that's smaller, you can use that number. 4 times 5 is going to be 20. 4 goes into 20, 5 goes into 20, right? 4, is there anything smaller? 4 times 2 is 8. 8 doesn't go into 5. 4 times 3 is 12. 12 doesn't go into 5. 4 times 4 is 16. 16 doesn't go... 5 doesn't go into 16. I never know which order to say that in. 5 doesn't go into 16. 4 times 5 is 20. 5 goes into 20. So we're going to stick with the same thing we did here, which is just take this side, multiply it by the denominator of this side, take this side, multiply it by the denominator of the other side. So we're going to be multiplying negative 3/4 by 5/5, and we're going to be multiplying negative 4/5 by 4/4. Good. 5 times 5, 5 divided by 5 times negative 3 divided by 4, negative 4 divided by 5 times 4 divided by 4. Now you're just going to multiply straight across. 5 times a negative 3 is going to be a negative 15. 5 times 4 is going to be 20, like we practiced, like we saw, the common denominator. Negative 4 times 4 is a negative 16. 5 times 4 is 20. Now I have the common denominator. So we had 4 and 5 as our denominators. Now we have 20 as both denominators. That's what we want. That's what we want when we say we want a common denominator. Now, when you have a common denominator, you keep that denominator and you just add the top numbers. Here it's a 15 and a 16. They are both negatives, so we're going to treat them. We're not going to subtract them, we're going to add them. We get a 31, but they were both negative, so it's a negative 31. We're going to treat them as though they were positives, just add them together. 15 and 16 is 31, but they were both negative, so it's a negative 31. Good? It's a lot of work, I know. All right, what if you have more than one term that you are adding or subtracting? Here we're combining 12 with negative 5 with negative 7. Combine 2 at a time, go from left to right. You're also welcome to use your calculator. 12 minus 5, positive 12, negative 5. So we're going to subtract. 12 minus 5 is 7, and then keep the sign of the bigger of the two. 12 is the bigger one, it's a positive. So that becomes a positive 7 minus 7. 7 minus 7 is just 0, right? 0 doesn't have a positive or a negative sign. Here, again, left to right, 9 minus 6. So we're going to start with 9 minus 6. It's positive 9 and negative 6, so we'll subtract. 9 minus 6 is 3. The 9 is positive, so the 3 is going to remain positive. Minus a negative 3. Remember when I said when we see minus a negative, we think plus. So now it's 3 plus 3 plus 8. I'm going to combine these two. 3 and 3, they are both positive, so it's just a 6. 6 and 8. 6 and 8 is 14 because they are both positive, so you just simply add 6 and 8 and keep the sign a positive sign. Here we go. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. All right, -9 and -5. Pause the video and try it without me. These are both negative, so we're going to combine 9 and 5. 14. Bring down the plus 11. Remember, minus a negative just becomes a big plus sign. Plus 7. Good. And then we'll go on to just combine these two. -14 and 11, they are different signs. So we want to take 14, subtract 11, we get 3. Okay. If they have different signs, you subtract them. If they have the same signs, you add them. 14 minus 11 is 3, but the 14 was a negative, so it's going to be a -3. Again, we have different signs. A -3 and a 7, but this case, the 7 is the bigger absolute value. So 7 minus 3 is 4. The 7 was positive, so the 4 is positive. So we have a 0, a 14, and a 4. That was adding. Combining really includes subtraction as well, because combining could be called adding a negative, right? So you're always adding, but are you adding two positives, a positive and a negative, or two negatives? In which case, when you're adding a negative, you could call it subtracting, but irrelevant. All right, multiplying real numbers. The product of two numbers with the same sign is a positive number. The product of two numbers with different signs is always a negative number, okay? And then product property of 0 is anything. A means anything, right? A variable means anything. X means anything. Y means anything. We don't know what the number is, so we put a letter instead. Anything times 0 is 0. So we're moving on from adding and subtracting to multiplying. -3 times 8. We said if the signs are different, the answer will always be negative. If the signs are the same, the answer will always be positive. Good. These are different signs, so it's always going to be negative. These are the same signs, so it's always going to be positive. This is 0. It doesn't have a sign, so 0 times anything is just 0. A positive times a negative is always going to be a negative because those are different signs. Different signs always gives you a negative answer. The same sign always gives you a positive answer. Anything times 0 is 0. All right. Just use your calculator. 3 times 8 is 24. So it's a -24. 5 times 2, ignoring the signs because we already decided a negative times a negative is a positive, according to that rule. So it's a +10. 0 times a -50 is 0. A positive times a negative is a negative. 10 times 5 is 50. Good. So we have -24, 10, because we don't need a sign for a positive number, and -50. All right. Down here, when we are multiplying fractions, it's actually way easier than adding or subtracting fractions. And we're not going to talk about dividing fractions today because a fraction is already a division, right? The fraction, oh, I'm very bad at finding the fraction on my calculator. Yes. The fraction 5/6, oh no. The fraction 5/6 is the same as taking the number 5 and dividing it by the number 6. 8 divided by 4 is 2, but, oops. 8 divided by 4 is 2, and the fraction 8 halves, oh, 8 halves, sorry, I didn't even do the same fraction. So 8 halves is 4, 8 divided by 2 is also 4. So when you see a fraction, just think division. Should have practiced that. All right. When we were adding, when we were subtracting the fractions, we needed to find a common denominator. When you are multiplying fractions, you do not need to find a common denominator. You just multiply straight across, okay? Look at this one. It's negative, right? It's a negative times a positive, so those are different signs. Different signs mean the sign of the final answer is going to be a negative always, okay? So now we can ignore the signs. 5 times 1 on the top is 5. 6 times 4 on the bottom, don't hesitate to use your calculator. There's nothing wrong with it. It's 24. It saves you time, unless it doesn't because you're doing it in your head. So negative 5/6 times 1/4 is negative 5/24. Good? Okay. Here we have, just as we were doing before, just go from left to right in order. 5 times 0, just 5 times 0 is going to be 0, and then carry the remainder with you. The rest of the equation, the expression, because there's no equal sign. 5 times 0 is 0. 0 times a negative 3 is also going to be 0 because anything times 0 is 0. So it doesn't matter if you have the longest multiplication problem in the world. If one of the terms is 0, your whole answer is going to be 0. Good? Here we have a positive times a negative, so those are different signs, so we're going to call that a negative answer. We know that answer is negative, and we can just put it in our calculator. 6 times 2.3 is 13.8. So this one, I know it's valuable to, I know it's fine to put it in your calculator, but it is valuable to understand that if it's two terms, one is positive and one is negative, the answer is always going to be negative. If they are both negative, it will always be positive. If they are both positive, it will always be positive. Here, we're just going to work left to right, okay? Negative times a negative is going to be a positive sign. 1 times 6 is 6, okay? And then we have to bring along the negative 7. Positive times a negative is always going to give us a negative answer. 6 times 7 is 42, so it's a negative 42. Dividing numbers. The quotient of two numbers with the same sign is a positive number. The quotient of two numbers with different signs is a negative number. Quotient means divide. It might look like this. It might look like this, right? 1 divided by 2, or it might just look like 1/2. Those are the same value. 1 divided by 2 is the same as, nope. 1 divided by 2. Oh my gosh, I'm not even showing you. 1/2 is 0.5. What? 1/2, not fraction, decimal. 0.5, 1 divided by 2 is also 0.5. All right. The quotient of two numbers with different signs is a negative. It's a positive and negative, so it's going to be a negative answer. Negative and a negative, so that's going to be a positive answer. Negative and a positive, so that's going to be a negative answer. A 0 and a negative 7. I don't know. 8 over 0, I don't know. They didn't really give me a rule for that, right? 42 divided by 7 is 6, so this is a negative 6. Negative 16 divided by negative 2 is just 16 divided by 2, 8, and it's a positive 8 because it's a negative divided by a negative. Negative 80 divided by 10, 80 divided by 10 is 8, but it's a negative 8 because that is a negative divided by a positive. Those signs are different. 0 divided by negative 7, it's better to just use your calculator because it's easy to forget, but if the 0 is on top of the fraction, the answer is 0. And if the 0 is on bottom, the answer is just called no solution. Sorry if my calculator wasn't getting low enough. I wasn't looking at the computer screen. I was just looking at my paper. Okay. Oh, we are going to divide fractions. When you divide two fractions, remember multiplying? Multiplying was pretty easy, right? You just multiply straight across. So to divide, what you want to do is keep, flip, change. The KFC process to change it from a division problem to a multiplication problem, because we like multiplication problems. We don't like addition or subtraction because then you have to worry about the common denominator. With multiplication, you don't have to worry about the common denominator. You just multiply straight across, right? This isn't multiplication, this is division. KFC means keep the first term or the first fraction. Okay? Keep the first term is the K. Flip the second fraction. And then change the sign from a division sign to a multiplication sign. Isn't that nice? All right, let's do it. So K is for keep. Keep negative. Well, first of all, a negative divided by a positive is just going to be a negative. So we're just going to call that negative and we're going to ignore it, okay? Keep 5/9. That's the K. We're done. All right. F, flip the 2/3. If you're going to flip the 2/3, what that means is the 2 goes down here and the 3 goes up here. So instead of 2/3, you have 3/5. And then change. All right, well, I will have cut and fixed this. What happened is, instead of a 2, I wrote a 5 here. And then I did a bunch of math, and hopefully I erased it. And now you're just cutting all of this out. Ignore all of this. This is a 2. This should be a 2. 9 times 2 is not 45. 9 times 2 is 18, right? So that becomes 15 over 18. Good? And then what I was trying to do is when I got 15 over 45 is I divided it by 5 to simplify it. 15 and 18, you always want to make sure there's not a number that you can divide out of your fraction. So 15 and 18, you can divide them both by 3, right? 15 divided by 3 is 5. 18 divided by 3 is 6. So when I take 15 divided by 3, 18 divided by 3, I get 5 over 6 as my final answer. Okay, I divided 3 out of both the top and the bottom. You could also see when we're saying 5 times 3 and 9 times 2, you can simplify. 3 divided by 9 is also 1 divided by 3. In that case, you have 5 times 1 over 3 times 2, which is 5, 6. I know this is complicated at first, but it will get easier the more you do it. It's worth doing just to have fluency with fractions as you move forward in algebra classes. All right, we're going to KFC this again. Ooh, and I'm sorry, it was a negative. Forgetting everything. Negative 5 times 3 over 9 times 2 is a negative 15 over 18, which is a negative 5, 6. Excuse me. Again, negative times a negative is going to be a positive. So this sign we don't have to worry about because you always forget the negative. You never forget that it's positive. It's a positive. We can ignore the signs. 2 sevenths remains 2 sevenths because that's called keep. 1/5 becomes 5 over 1 because it is flipped. And then we change from a division to multiplication. Change. Okay. Now, all that means is 2 times 5 on the top over 7 times 1 on the bottom. There's nothing I can simplify out. 3 times 5 times 3, 9 times 2. I could simplify the 3 and the 9. There's nothing that I can divide out. There's no 2 on the bottom. There's no 7 on the top. 2 times 5 is 10. 7 times 1 is 7. Let's just check the sign. A negative times a negative is always going to be positive, so it's just a positive 10 sevenths. All right, moving on to exponents. Exponents that are natural numbers are shorthand notation for repeating factors. Factors means multiplication, okay? Exponents are a shortcut for multiplication. The exponent itself tells us how many times to multiply the base. Here, the exponent is 4, the base is 3. That means I'm going to multiply 3 times itself 4 times, okay? It's 81, or I could just type in 3 to the 4th, 81, okay? So 3 is the base, 4 is the exponent. You can also call the exponent the power. In the order of operations, we have parentheses or grouping symbols. And then we have exponents. So do the exponent, distribute the exponent, or solve the exponent if possible before you add, subtract, multiply, or divide. Okay? Three to the power of 4, we just did that, is 81, right? Here, the exponent is just attached to the 3. Here, the 2 is attached to the negative and the 5 because of the parentheses. So it's now negative 5. How many times do we multiply negative 5 by itself? Twice, because there's a 2 as the exponent. So negative 5 squared is 25, or negative 5 times negative 5 is 25. If you forget the exponent, or sorry, if you forget the parentheses, you will get the wrong answer. Negative 5 times negative 5, that might still be okay. Yes, that'll be okay. But if you don't use parentheses, where you see parentheses, you will get the wrong answer. It's not negative 25, it's a positive 25. Whereas here, it's a negative 36, because what we're saying is, oops, sorry, negative 6 squared is a negative 36, because what we're saying is we're saying negative 6 times 6, or negative 6 times 6. The negative stays outside, the 2 is only corresponding to the 6, the first term next to it. So it's a negative 6 twice, right? Because the exponent is a 2, negative 36. Here, you have 2/3 3 times. So we're going to multiply 2/3 times 2/3 times 2/3. I don't know why I have parentheses, because they had parentheses, I guess. No, I guess that just means you need to carry it. I don't know why I wrote those parentheses. 2 times 2 times 2 is 8, because 2 times 2 is 4, 4 times 2 is 8. 3 times 3 is 9, 9 times 3 is 27. So our final answer for 2/3 to the 3rd power is 8/27. Good? All right, just like addition is the opposite of subtraction, multiplication is the opposite of division. If you take a number and square it, the opposite of that is taking the square root of that number. This is x to the 2nd power. This is taking the second square of, or second root of, that same number. The inverse of squaring a number is taking the square root of a number. A number is a square root if the number a, so the square root of a is b if b squared equals a, okay? The square root of 25 is 5 because 5 squared is 25. You see that? The square root of a is equal to b if b squared equals a. That is how they are related. All right. So the square root of 16 means what number can I multiply by itself 2 times to get 16? 4. Because 4 times 4 is 16. Okay? The square root of 1 over 36 is the square root of 1 over the square root of 36, just like the square root of 16. The square root of 1, what can I multiply by itself twice to get the number 1? 1. What can I multiply by itself twice to get 36? It's helpful to just learn these. Well, we know it's 36. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. So it's nice to just kind of memorize perfect squares. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. You can Google it if you want. 7 squared is 42. I always forget. I think 7 times 6 is 42, and then 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared nicely is 100. Okay. The square root of 36 is 6 because 1 times 1 is 1. 6 times 6 is 36. So I can work backwards and get 6 squared is 36, 1 squared is 1. The cubed root means what can I multiply by itself 3 times to get this number? Okay, so here are the square roots. Less common, but you can also make a list of them, are cubed roots. So 2 cubed is 8. 3 cubed is 27. Because 3 times 3 times 3 is 27. Good. 4th root, don't worry, you will not see this, but 2 to the 4th is 16. So the 4th root of 16 is 2, because 2 times 2 times 2 times 2, that's how many times you need to do it? 16. So here, because that's a 3, you need 3 times. That number times itself 3 times. That number times itself 4 times. If there's no number here, it's an understood 2. So these are usually 2s. So you're looking for something to multiply by itself 2 times. 1 is multiplied by 1 twice. 6 is multiplied by itself twice. Okay, let's talk about PEMDAS again. What order to do the computations? Okay, parenthesis, I like to call grouping symbols. It includes parentheses, but it also includes brackets. So we have parentheses, we have brackets, we have these kind of brackets, fancier brackets. We have division bars, interestingly. The division bar is a grouping symbol. We have the absolute value bars. We have the radical. Okay, so if it's inside parentheses, it's a group. If it's inside brackets, it's a group. If it's above or below a fraction bar, it's a group. If it's within the absolute value bar, it's a group. And if it's all under a radical, it's a group. Good, so those are the grouping symbols. Do those very first, then do exponents, which is what we just talked about. These are the exponents. Then multiply and divide from left to right. So you could even call this grouping exponents. Divide and multiply are on the same level. add and subtract are on the same level from left to right. So you could call it GEDMAS, GEMDAS, PEMDAS. That's the order though. Grouping symbols, exponents, multiply and divide on the same level, add and subtract on the same level, left to right. Let us practice. So you could even make yourself a list. Parentheses, exponents, multiply, divide, add, subtract. Okay. Do I see any parentheses, any grouping symbols? No. So I'll start with exponents. 5 squared is 25. 6 divided by 3 plus 25. Now I want to do division before I do addition. 6 divided by 3 is 2. 2 and 25 is 7. Good. 27. So not good. No, very bad. Here I have 2 plus 5 times 2 minus 6 squared. The first thing I see are parentheses. The first thing I'm looking for is parentheses, and I see them. So I keep 2 and 5 being multiplied by 2 minus 6 is a negative 4 squared. So that's the end of my parentheses. Negative 4 squared is my exponent. So I'm going to say 2 plus 5 times, what's negative 4 squared? Remember to include your parentheses or else you will get the wrong answer. So with the parentheses, I get a positive 16. So it's 5 times 16 because they're right next to each other with parentheses. So that means 5 times 16 plus 2. I'm going to do the multiplication before I add. So 16 times 5 is 80. I know my calculator says negative 80, but that's because I was showing you how to get the wrong answer. So it was parentheses, negative 4 squared. We get positive 16 times 5. Good. And if you put it into your calculator perfectly, the calculator will do order of operations. A grouping symbol is, so it will give you the right answer if you input it correctly, but I often don't input it correctly. I make mistakes. Okay. Remember, this is a grouping symbol and this is a grouping symbol. So we're going to solve all of this before we divide it by this. 6 plus 9 divided by 3, I need to do division before I do the addition. So that's going to be 6 plus, what's 9 divided by 3? It's 3. 6 plus 3. Here I have 3 squared. 3 squared is 9. 6 plus 3 I'm going to do before I divide because this is a grouping symbol still. 6 plus 3 is 9. 9 divided by 9, if you put it in your calculator, will give you 1. Okay? Simplify the numerator, simplify the denominator before you divide them. All right, here we have 1 plus 2 times the quantity of 5 times the quantity 2 plus 2 times 3 plus 1 minus 10. Good. We see grouping symbols. I see grouping symbols within grouping symbols. You should start with the innermost grouping symbol. So that's going to be the 2 times 3 plus 1. Within that grouping symbol, you still want to follow PEMDAS. So you have multiplication and addition. Do the multiplication first. So 2 times 3 becomes 6. That's now 6 plus 1 times 5 minus 10 times 2 plus 1. Okay, I'm reading it a bit backwards, but I'm reading it in order of operations. I still have an innermost parenthesis, so I'm going to say 6 plus 1 is 7. That's going to be multiplied times 5. That's going to be subtracted. 10 is going to be subtracted from it. It's going to be multiplied by 2, and we're going to add 1 to it. 5 times 7 minus 10 is all within a grouping symbol. What should I do first? I should multiply, right? 7 times 5, 35. Now that is 35 minus 10 within a grouping symbol times 2 plus 1. 35 minus 10 is going to be 25, but that is still times 2 plus 1. Here, my only operations left are addition and multiplication. According to this list, I need to multiply before I add. 2 times 25 is 50. 50 and 1 is 51. Good. All right, this guy is complicated. Here is a grouping symbol, and here is a grouping symbol. And we're going to want to do all of this and all of this independently like we did up here, okay? Don't worry. Keep the -5 the same. Keep the square root because there's something under the square root. 30 minus 5 is going to give us the number 25, right? Outside, make sure it's clear when you write it for yourself. Outside of that radical, we have plus -2 squared over, what can I start with here? Here I'm going to start with the grouping symbol. So I have 4 squared plus the absolute value of 7 minus 10. 7 minus 10 is the same as 10 minus 7, but with a -3, right? Because we take the absolute value of 10, subtract the absolute value of 7, we get 3, but the 10 was a negative, so it's a -3. Good. -5. What's the square root of 25? It is 5. Those are right next to each other, so it means multiply. Plus -2 squared over 4 squared is 16 because 4 times 4 is 16, plus the absolute value of -3 is 3. So I did both of those at the same time, but I knew that they wouldn't really impact each other. So you could take another step and say this is 4 squared plus 3, 16 squared plus 3, for further clarity. All right, on the bottom, I see that 16 plus 3 is the only step left, so I can just call that 19. Good. Up on the top, though, I have a negative being multiplied by a positive being added to an exponent. So my exponent is my next move, according to the order of operations. A -2 squared, you can put it into your calculator. You get a 4. Now I have -5 being multiplied by 5 being added to 4 over 19. Next thing I want to do is multiply before I add. So I'm going to multiply -5 times 5 is a -25 plus 4 over 19. The reason I multiplied before I divided is that this is a whole grouping symbol, remember, okay? So we want to do all of this before we divide it by 19. -25 plus 4. They are not the same sign, they're different signs, so we subtract. 25 minus 4 is 21, but the 25 was negative, so it's a -21 over 19. Make sure you can't divide them by anything. I can say 21 divided by 7 is 3. Can I take 19 and divide it by 7? No. Can I take 19 and divide it by 3? No. All right. Ooh, last one. All right. I think this was a mistake. There's nothing here. There's nothing here. Evaluate just means substitute, okay? Be very careful when you substitute. -3 times y squared, y is -4. So I'm going to call that -3 times -4 squared. Still following PEMDAS, okay? -4 squared is going to give me 16. And then 16 times -3 is going to be -48 because the signs are different. A negative times a positive is always a negative. 3 times 16 is 48. Good? Okay, this one looks a bit more complicated. The square root of x when x is 9 over y when y is -4 plus that same -4 over an x, but without the radical. Good? Okay, the first thing I'm going to do is the radical. The square root of 9 is 3. 3 divided by -4 plus -4 over 9. Now, all I have is fractions, so all I'm doing is combining fractions, okay? 3/4. It's a 3 divided by a -4. Think about this. When I take a positive number divided by a negative number, I get a negative answer. So I'm just going to call it a -3/4. It doesn't matter if the negative goes with the 3 or with the 4, but not with both, right? Because -3 divided by -4 gives me a positive of that number. So it's just out in front. Plus -4/9. Same problem here, okay? What do I need to do? I need these to have common denominators. The easiest way to do that is take 4, multiply it by 9, do the same to the top. Take 9, multiply it by 4, do the same to the top. Okay? Now, a positive times a negative is going to make that a negative. 9 times 3 is 27. 9 times 4 is 36. Negative times a positive is still a negative. 4 times 4 we know is 16. 9 times 4, because we just did it over here, is 36. So this is what we wanted. Now we have negative 27 over 36 plus a negative is the same as minus 16 over 36. Okay, this is our very last problem. I know it's very difficult, but think about this, okay? Think about it not as two fractions, but as two numbers. Oops. So we have a negative number and a negative number. That means we can just add them together, okay? And our answer is gonna be negative. We're gonna keep the same sign, but we're just gonna add these because they're both the same sign. They're both negatives. Remember with a fraction, now we're going back to the fraction rules. If it has a common denominator and we're adding and subtracting, we just keep that common denominator, okay? Now we're gonna say 27 and 16, same sign, so we're adding. 27 plus 16 is 43. Our answer is 43/36. And we can just make sure negative 27 minus 16 is also negative 43. Again, you want to think about any numbers that 36 can be divided by, that 43 could also be divided by. I know that 36 can be divided by 6. Can 43 be divided by 6? No. 36 can be divided by 3, right? Can 43 be divided by 3? No. 36 can be divided by 2. Can 43 be divided by 2? No, because it's odd. So you just want to go through like that, make sure there's no way to simplify your fraction, but then you are done. All right. Thank you so much. Have a wonderful day. See you next time.